Alright, so this is part two. I'm just going to pick up where I left off, which is at straight tube boilers. I am, for those of you who may just now be joining us, I am reading from High Pressure Boilers, 6th edition. Frederick Steingress, Harold Frost, and Daryl Walker are the authors. We've been going over steam boiler types, and we are in water tube steam boilers. We're going to talk about straight tube boilers. A straight tube boiler is a water tube boiler with box headers connected together by straight inclined water tubes. In a straight tube boiler, the water enters a box header and circulates through the inclined tubes to another box header where the steam separates from the water. Downcomers allow for circulation between the lower drum and the box headers. When heated, the water expands in volume, becomes less dense, and moves toward the rear header where the steam bubbles begin to form. The steam bubbles rise up the rear header to the steam drum. Here they break through the surface of the water, entering the steam space. Generally, the tubes in straight tube water tube boilers are expanded into the drums and headers and are slightly flared to prevent leakage. Bent tube boilers. A bent tube boiler is a water tube boiler with multiple drums connected by shaped tubes. Circulation becomes more complex in a bent tube boiler. The rear tube bank acts as a downcomer to the mud drum. Most of the steaming occurs in the front tube banks. The steam and water mixture enters the steam drum below the water surface. Bent tube boilers operate at higher pressures and higher steam capacities than straight tube boilers. The design eliminates the need for headers. Common bent tube boiler configurations include A, D, and O styles. Membrane boilers. A membrane boiler is a water tube boiler that uses strips of metal alloy welded between the tubes to form a seal. This eliminates the need for a seal welded inner casing. The gases of combustion pass across the tubes to heat the water, and the boiler vessel is gas tight, insulated on the outside, covered by a steel casing. Membrane boilers are a recent design and are used where space is limited. They can be used for heating water or when steam is required. Flex tube boilers. A flex tube boiler is a water tube boiler in which replaceable serpentine tubes are connected to the upper and lower drums and surround the firebox. The tubes have a tapered bushing welded on the ends, which is fitted into the header by a press fit. This allows the tubes to be replaced without welding. The serpentine shape allows the tubes to expand and contract. A flex tube boiler is normally used where floor space is limited. Other boiler types. There are several other types of boilers commonly used. These boilers use alternative fuels or heat that otherwise might be wasted. Refuse boilers and waste boilers are very similar. They may burn similar fuels, and the name used varies from one industry to another. An electric boiler is a boiler that produces heat using electrical resistant coils or electrodes instead of burning a fuel. Electric boilers operate similarly to boilers fired by fuel oil, gas, or coal, except that electric boilers do not burn a fuel. In resistance coil electric boilers, electricity flows through a coiled conductor. Resistance created by the coiled conductor generates heat. Resistance coil electric boilers are used as low capacity boilers and are more common than electrode electric boilers. In electrode electric boilers, heat is generated by electric current flowing from one electrode to another electrode through the boiler water. Conductivity of the boiler water will affect the flow of electricity and the amount of heat generated. Conditions that affect boiler water conductivity must be carefully monitored to ensure safe and efficient operation. For optimum efficiency, the manufacturer recommendations for boiler water conditioning should be followed. Refuse boilers. A refuse boiler is a boiler that uses the municipal solid waste that would normally go to landfills. Using solid waste in refuse boilers helps minimize the impact of landfills on the environment. These boilers are designed with sophisticated controls to handle varying load swings. Most refuse boilers use an inclined grate design or a rotary kiln combustor. The boiler is classified as a refuse-derived fuel boiler if the solid waste is burned outside the boiler furnace and the gases are burned inside the furnace. The boiler is classified as a mass-burning boiler if the municipal solid waste is not sorted or only minimally sorted before it is introduced into the boiler. Most refuse boilers are water tube boilers using special tubes and furnace designs to handle the slagging and corrosive nature of the fuel. Care must be taken to design the boilers to handle the bottom ash residue and the fly ash created from the solid fuel. Waste boilers. A waste boiler is a boiler that uses fuel from an industrial process that would normally be wasted. Waste boilers can use the heat from the incineration of industrial waste such as wood, bark, sawdust, garbage, tires, used oil, industrial byproducts, and black liquor residue from the paper industry. These boilers are usually conventional fire tube or water tube boilers fitted with special burners and burner accessories. In some instances, there are special equipment regulations requirements to ensure that boiler emissions meet environmental regulations. Heat recovery steam generators. A heat recovery steam generator, HRSG, is a boiler that uses heat recovered from a hot gas stream, such as hot exhaust gases from a kiln or from a gas turbine. Does not require a burner to burn a fuel because the hot gases already exist as a waste from another process. HRSGs have four major sections: the economizer, the evaporator, the superheater, and preheater. The economizer section is a heat exchanger that heats the feed water before the exchanger that vaporizes the water to produce saturated steam. The superheater section is a heat exchanger that heats the saturated steam to a temperature above the saturated temperature to produce dry steam. The preheater section is a heat exchanger that heats another medium, water, glycol, air, etc., to be used in the plant. HRSGs can be modular, packaged, or once through steam generators. Modular HRSGs are larger units and the sections are built off-site, shipped in sections, and then erected on-site. Packaged HRSGs are smaller units that are shipped as a unit that was fully assembled at the factory. Once through the steam generators are a specialized type of HRSG without boiler drums. In this design, the inlet feed water follows a continuous path without segmented sections for economizers, evaporators, and superheaters to produce the superheated steam. So I can see right now that trying to read through all this on video aloud is going to take too much time. And I'm also not able to look, when I'm reading, I'm not able to look at the pictures and really focus on the information. I'm focusing more on reading and maintaining a steady pace or rhythm. So I'm not sure that this is effective. However, I can see going through the reviews at the end of each chapter and reading through some of those questions, which I have converted into statements, as a refresher. I'm going to think about it. So that's it for today. Thank you. Like, subscribe, share if you enjoy stationary engineering or boilers, or are planning on getting into the industry, getting your licenses, looking for educational resource-based material to help further your career in the engineering industry. Then hope you found this useful. Thanks.